Use the method of cylindrical shells to find the volume generated by rotating the region bounded by the given curves around the specific axis. Let's start by sketching this. I know I'm going to be rotating around x equals 3, so let's make a note of that. And then we want to be restricted at y equals 8. And we're looking at the curve y equals x cubed. We know y equals x cubed goes through the origin, goes through 1, 1, then it goes to the point 2, 8. So if we rotate this around x equals 3, it will land over here and look something like this. So then we'll rotate this and get this shape. The volume will be the integral from 0 to 2. We went from 0 to 2 on the x. And then the circumference, 2 pi. Typically we do x here, but since we're not rotating around the y-axis, we're actually rotating around x equals 3. We want to change that to 3 minus x instead of just simply putting an x here. And then the height is coming from our equations. We have 8 minus x cubed and dx. Simplifying this, I'm going to pull the 2 pi out and distribute. We have 24 minus 3x cubed minus 8x plus x to the 4th. Next, I just want to reorder that to make it look a little neater. We have x to the 4th minus 3x cubed minus 8x plus 24. And now we integrate. Leave 2 pi on the outside. We get 1/5 x to the 5th minus 3/4 x to the 4th minus 4 x squared plus 24x. And we want to integrate from 0 to 2. So we go through and we'll plug in 2, our upper limit, everywhere we see an x. And typically we also plug in the lower limit, but plugging in 0 is just going to give us a subtract 0. So there's no need to do that. If we simplify this, we get 264 pi over 5, the volume of the solid.